Hello everyone, episode 12. Let's get started. So, where we left off last time is we were able to click on the map and then our knight would walk towards that position. So let's have a quick look. Let's rotate a bit. Here's our knight and let's walk a bit. Okay, so the knight is walking, he's changing facing direction, and then we're clicking somewhere, and each time the knight starts from the exact same position. And the reason is we're never really updating the entity's position itself. We're always hard-coded going from this position. So let's fix that first. And just to show that we're not cheating, if we go up where we're creating our Dijkstramap, first let's make sure we start from our entity's position. So we're still using the first entity in the array, that's the knight. So we only need the X and Y position. So let's try again and see if this miraculously solved it. However, it didn't, because we're still never updating the entity's position. So let's first use a quick and dirty approach. So let's go to where we're creating our animation. That's in the create follow path animation for entity. And what we can do is we can create an additional action. Let's call it complete action. And this one will be an SK action of a custom action type. This takes a duration. Now, for some reason, this cannot be 0. If it's 0, then it never gets triggered, but it can be a very small value. Basically, we're not interested in how long this takes. We want it to be more or less instantaneous, but we need a value higher than 0. So I'm choosing 0.001 in this case. And what I want to do is I want to make sure that our path needs at least 2 entries. I think a path by default, by definition, always has one, but this is just to be careful because I need to be able to take our entity's position and set it to the path, the last position, and that's path count -1. But I also need to set its rotation correctly, and that's a rotation from look rotation for the path for the last one minus the second to last one. And that's why we need to make sure path is at least 2, otherwise this will crash because we're having an out of bounds array. And this might not work if for whatever reason we're unable to create a rotation. We're returning an optional. In that case, we'll just use the existing rotation as a default value. Oh, and we need self here. And here as well. Can we auto fix this? Hopefully. Not yet satisfied. Okay, sure. So a lot of self dots, whatever, it should work. Next, what we'll do is we'll take our move actions and append this action to be run as well. So, and then we return a sequence of all these actions where the last action is this complete action. So let's run this. And let's see what happens. So let's move again to a position. And let's move to another position. And look, our path now updates based on the last position where we were. So this, well, cool and all, and we could say, we're done, let's call it a day. However, personally, I'm not really happy with this solution. First of all, the soft dots aren't very nice here either, and we should make sure we don't have reference cycles, but that's not my biggest point right now. My biggest issue with this is that we now create a hard coupling and a hard dependency between the game's logic, moving and updating positions, towards our visual systems that are creating the animation. Ideally, I would like to have the animation system and the visual representation not really be involved, or at least as little as possible, with how the internal representation of the game looks like. And that means we need to introduce some decoupling. And the decoupling I'm going to use is I'm going to introduce the command pattern. And the command pattern is a well-known programming pattern. There's actually a very good write-up about the pattern on gameprogrammingpatterns.com. I'll leave a link in the description below. And it really helps simplify or add some decoupling in situations like this. And also we'll see that having the command pattern in place makes working with UI easier, makes working with AI easier. So there's a lot of mileage you can get out of that one. So let's comment out all this stuff and let's implement a more proper solution. And I want to do so by starting to introduce in our entity something I would call a current action. That's basically the thing the entity is doing. And what I want to do is I want to keep track of an action, sort of store it, and then at some point in time complete the action. And by introducing sort of a delay, or first storing an action and later and then later completing it, I can do all sorts of stuff in between. I can ask for confirmation in a UI, or I can first play an animation and then have an action complete. And there's a lot of advantages in having a bit of interaction that way. So let's get started. So let's look at our entity test, and also let's open a second editor, and in our entity test, let's start working on our action system. And in particular, I'm interested in completing action. So, and we haven't defined anything about an action yet, but we'll do so in a bit. So basically the API I want to introduce is I want to have a function called complete current action. And what it does, it sets current action to nil. So let's have an entity. Somewhere in the world. And let's make sure the current action is some form of dummy action. We'll define them as we go along. Then we want to have, then we want to call complete current action. This one we also need to define. And finally, we can assert that entity.currentAction is nil. So let's get rid of these compiler errors, and we can start by introducing a current action. But that requires, that can be an optional of type action, but that requires an action. Action is what I will be calling a command. So let's create another Swift file called action.swift. and this will contain a protocol called action, and that's it for now. So at least this one should now compile. Okay, cool. This also means that we can define a function called complete current action. So this should help even more compile, and we need a dummy action that's basically an empty implementation of this action protocol. This is our dummy action. And now this one too can compile. So let's try running these tests. And the test fails because the current action is still set to dummy action. We're never setting it to nil. So let's go into our function and add the code required to do that. Go to the entity and say current action equals nil. Okay. So basically, this way we can only execute an action once. However, the actions aren't doing anything yet, so that's the second thing I want to make sure that our test complete the current action calls the actions complete function. And to do that, we'll quickly create a specific type of action. I'll call it a block action. It will conform to the action protocol, and it will have a block which is a closure that executes something. Basically, we're passing in some code to execute. And then I want to have a function called complete that I can call, and that just executes the block. Then again, I want to have an entity, or let's copy paste some of this code. I want to create a variable called count. This will be my spy to see if the action actually correctly gets called. We'll create a block action, and we'll pass in a closure that increments count by 1. Then we'll call complete current action, and finally we can assert that the count is now 1 instead of 0. So let's run this one. So it fails because we don't ever call this code. So what we would like to do is do something like current action dot complete, and then set it to nil. And that does work specifically for a block action because that has a function called complete defined. However, an action itself has no definition of the complete function yet. So I want to create a protocol requirement that these should always have a function called complete. And also, because now my dummy action is complaining, I want to have a default implementation for the complete function that does nothing other than print completed action ourselves. Let's try again. And now the test passes because we're correctly calling also the complete function. Okay, so we now have entities that can store an action and completing an action. And upon completion, repeating an action, the actions code, whatever that is, gets called, as well as currentAction gets set to nil. So let's implement a proper action that does something useful. And let's start by defining a MoveAction. So we have our action here. Let's create a new test file. We will call them action tests. And this is where we'll put in all the tests for the specific types of actions that we expect. So let's import action test and import our project as testable. Create a final class action test, actually test case. And let's start with the MoveAction test. So our first test should be that our MoveAction complete sets position. So let's create an entity. Add a start position and let's create a path. We'll just hard code a path right here. Hold zero from 0 to let's see. First we go down a bit, and then we also go to the right a bit, and also we'll be walking slightly up a hill. So we're really ending up in a different position than where we're starting. Then let's create a MoveAction, which we didn't define yet, but we'll do so in a bit. The MoveAction should have an owner. That's the thing we want to move. That will be our entity, and it will have a path, or it will keep track of the path. Then we should be able to complete the MoveAction, and then we can assert that our entity's position is equal to the last part, the last position in the path. Okay, so compiler complaining because we don't know what a MoveAction is yet, so let's define one. This will be an action, and it should have an owner, and that will be an entity, and it will also have a path. And I want to be a bit careful here. I'm going to make entity an optional. And the reason I want to do that is I want to prevent a hard reference cycle between an action that contains a pointer to an owner, while the owner might also, through the currentAction, have a link to the MoveAction. So that's why I'm making it an optional. Okay, so this should now compile. Let's run the test. The test fails because we're not updating position yet. So let's create a complete function here as well. That way the default one doesn't get used. And I want to make sure that we have an owner. Otherwise we'll just return. If our path we'll just set our owner.position to path count -1. And that also means that I need to check that it's at least 1. So let's run the test again. Okay, so now the test succeeded. We're correctly setting the position. We also want to set the rotation. So let's make a copy of this test. But in this case, we're interested in setting the rotation. This requires a few slightly simpler path. Let's say we're moving some different direction because I really want to change the facing of the player. So we're moving, I think, downwards. We have the move action, the path, and then we can assert that rotation ends up being 315 degrees. So let's run the test. Okay. We should also update the rotation. We can use the same trick we used last time, but we do need to check that we have more than 2. So let's go into, let's make sure that our owners dot rotation equals, and I'll get all the stuff again, rotation from look direction that required. The last one minus the second to last one. And we are only interested in the 2D versions. And we can use the current rotation as a default if we can't determine which one to use. So let's run the test. And now the test passes. So we have a move action implemented. Let's change our game scene to use this. And the first step here is to get rid of some of this junk we added to show the path. So let's get rid of the path and select the coordinate here. And that will get rid of a lot of code, but that doesn't matter that much. We can also get rid of this one. Or actually cleaning up some of the code. We do want to show the code, so let's see if entities current action as a move action. So if the current action is a move action, and this one contains position, then we can set the color to blue. And this one returns an optional, but we'll use false as the default value, meaning that we won't be changing the color if no action has been set. So we can't use path is empty and this thing here anymore. But what we can do is we can check if we're indeed looking at entity 0. Then we can extract our move animation. Is a create follow path animation for entity. And if we get that one, we can run that move animation. Otherwise, we'll just repeat or just use idle animation. This fails because this one doesn't return an optional, but we'll get to that in a bit. So let's continue and see the next place where our code is complaining. So we want to get a coordinate in the path, but that doesn't work because we don't know the path. So what we need to do is check, make sure that we have a move action. Our current entities should have an action that's a move action. Otherwise, we'll return a nil. Basically, then we fail to create an action. Now we can do for coordinate in path, for coordinate in move action path. And path has 3D coordinates. We're only interested in 2D coordinates, so we need to make sure we're using the XY ones here and there. And let's see. And here as well. That also means we don't need to convert to 3D anymore because we already have a 3D coordinate. The same applies here as well. Now we just need to create a different complete action. So we do need some coupling to our animation system. But the big difference is I'm not going to tell the animation system what it needs to do for this specific action. I'm only saying it should call the entities complete current action. Okay. So let's see. So we now are able to basically translate a move action into an animation. At the end of the animation, we call the complete action, and this is a pattern that we can reuse for other types of actions going forward as well. So basically extracting the action from an entity, doing stuff to create it into an interesting looking animation, and at the last step, completing the animation. Now we just need to make sure that we're actually creating a movement action for an entity. So let's go into our touches began function, and we can get rid of this one because we don't have to select coordinates anymore. What we can do is create a Dijkstramap where the target is our entity's position. Then we can create a path to our clicked tile.xy using the Dijkstramap. And this path needs to be in 3D coordinates, so we map it to using convert to 3D. Then we take our entities and the current action and create a move action for this entity and the path we just created. And let's build and run. Okay, let's have a look. So here's a knight. The knight is moving. The knight is now standing here. Let's move somewhere else. Okay, so it looks like the behavior is the same as before. Only we added a bit of indirection and thus made our code a bit easier to use going forward. Also, we started getting rid of some of the hard-coded stuff that was in the game scene to roll paths and selected entities. That's all stuff that we want. Really don't want here. I just want to have the game scene be as focused on visualizing as much as possible. And we started by moving some of the data we're using more towards the entity than other places. So the entity now knows its path based on a move action that's set. And that is a pattern we can use for other types of actions going forward as well. For next time, I want to make a start with being able to control other entities as well. So I don't just want to be able to move this hard-coded knight here. What I want to do is I want to be able to click on one of the other units, for instance, the rogue or this knight, have that one selected, and then being able to click somewhere and run the animation starting there. Okay, so thanks for watching and have a good day.